using molarity as a conversion factor. Molarity is often going to be used as a conversion factor if you do reactions and you're using solutions and you want to use stoichiometry. Those solutions will be in milliliters, and you'll need to use molarity to get them to moles, not molar mass. So I'm going to look at a situation going from grams to milliliters and from milliliters back to grams. Let's say we are given a solution that is 0.25 molar NaCl. And number one, let's say we're asked to make up 500 milliliters of that solution. So we want to make 500 milliliters of 0.25 molar NaCl. Now this is the same question that you could be asked, and you could be using 500 milliliters of this, and you would be asked how many grams of NaCl are in it. But in order to make up the solution, you're going to need to know how many grams of sodium chloride to weigh out. We're going to go from liters to moles to grams. And going from liters to moles, we will multiply by molarity. From moles to grams, we will multiply by molar mass. So we'll start with 500 milliliters, and I'm going to put my molarity in as 0.25 moles for every 1,000 milliliters. Now again, those volume units have to be consistent. They can both be liters, they can both be milliliters, but they need to be consistent and they need to be accurate. And finally, I want to get rid of the moles, and I need to turn it into grams. And for NaCl, there are 58.5 grams per mole. At some point in here, you would need to put in the NaCl, and you could have it in here because that's what your solution is. So my milliliters cancel out, my moles cancel out, my answer's in grams. And if I use the data the way it's set up, I'm going to have 500 times 0.25 times 58.5 divided by 1,000. And this would tell me that I need 7.3 grams of NaCl. And if I'm going to make a solution, I will dilute to 500 milliliters. Or if I already have the solution, it will tell me there's that much in 500 milliliters. Now the other situation is you want to pour out 2 grams of NaCl, and you want to know how much solution contains 2 grams of NaCl. So for this example, we're going to go from grams back to moles and then to liters. We'll have a division by molar mass and then another division by molarity to get us where we want to go. So if I want to deliver 2 grams of NaCl, and I know that there are 58.5 grams in a mole, and I don't want my mole there, I want my mole up here. And then, oh good, it took it away. Well, there we go. There are 58.5 grams in a mole, and then I also know that my solution is 0.25 moles per liter. And those pieces will give me the number of liters I need that will be equivalent to 2 grams of NaCl. Now this time I'm doing divisions. I'll have 2 divided by 58.5 and then divided again by 0.25. And that would be 0.136 liters, which would be the same as 136 milliliters of my solution. And so if I poured out 136 milliliters, that would be equivalent to the 2 grams of NaCl. But these two setups are the setups that you can use to go from grams to moles to liters, or liters to moles to grams. The moles you'll get to either by using molar mass or by using molarity, depending on where you start. This ends up being really useful for chemistry. And